Ladies and gentlemen, in this video, we're going to talk about how to add and subtract positive and negative fractions and mixed numbers. So let's go ahead and get into the video. Before you can add and subtract any fractions or mixed numbers, they have to have a common denominator or the same bottom number in the fraction. And in number one, our denominators at the moment are 7 and 4. And the only way to get a common denominator is by utilizing least common multiple. So let's go ahead and find what number 4 and 7 have in common with each other. So I'm going to write down 4 and 7, and we are going to list the multiples of each number, or essentially count by each number. So for 4, we have 4, 8, 12, 16, 20, 24, and 28. And for 7, we'll count by 7. So 7, 14, 21, 28. And the first number that appears in both lists is 28, which is going to be our least common multiple. And that's what we want to turn our denominators to, is 28. So if we take a look at 12 and 3/7, so how do I get from 7 to 28? What can I multiply 7 by to get to 28? Well, I can multiply it by 4, but when I multiply the denominator by 4, we also want to make sure we do the same thing to our numerator as well and multiply by 4. Now for the other mixed number, 19 and 1/4, well, how do I go from 4 to 28? We're going to multiply by 7 in the denominator and the numerator. And now let's go ahead and make those changes by multiplying the top and bottom. So now we have negative 12 and 12/28 minus 19 and 7/28. And that's always the first step that you want to do, is make sure that your fractions or mixed numbers have a common denominator, because you can't add or subtract them until they do so. So now that we've done that, we want to move on to step 2 and decide, well, what rule or rules are we utilizing? And I always make my students memorize 2 rules, one for subtraction and one for addition. So since this is a subtraction problem, we're going to start with the rule in yellow, which is leave, change, opposite. So we're going to leave the first mixed number alone. So it's going to be negative 12 and 12/28. We're going to change subtraction to addition, and we're going to turn 19 and 7/28 to its opposites. So it's going to become negative 19 and 7/28. And now that it's an addition problem, we now want to utilize our rule in red. And it says same signs add and keep, different signs subtract. Keep the sign of the bigger number, then you'll be exact. Now it goes to the tune of row, row, row your boat. I actually sing it in my adding integers video if you want to listen to it. But we're going to utilize this whenever we have an addition problem. And that goes for integers, decimals, and of course fractions and mixed numbers as well. So taking a look at our mixed numbers, they have the same sign. They're both negative. So we're going to use the first part of that rule, same signs add and keep. So let's go ahead and add them together. And I'm just going to use any space that I have available just because it's going to take a decent amount of work here. So we have 19 and 7/28 plus, notice how I'm lining up my numbers out front and the fractions right above one another. And now let's go ahead and add our numerators first. So 7 plus 12 is going to give us 19 in our numerator. Our denominator is going to stay the exact same. We didn't do all that work to just make our denominator like 56. It's going to stay 28. And now let's add the numbers out front. Well, 19 plus 12 is 31. And the rule says same signs add, which we just added, but now we need to keep the sign that they had in common with each other. They were both negative, so my final answer is going to be negative 31 and 19/28. So I'm going to get rid of all of this just so we have space for number 2, and then I'll rewrite the answer right below number 1. So we had negative 31 and 19/28. And now let's go ahead and move over to number 2. Now again, step number 1 is a common denominator. And this time around we got lucky because the denominators are already the same. They're both 8. So then we can move right to step 2, and it's deciding, well, are we adding or subtracting here? And this time around we're adding. So we can skip the step of leave, change, opposite because it's not a subtraction problem. We're going to go right to the red rule. So same signs add and keep, different signs subtract. Keep the sign of the bigger number, then you'll be exact. Well, 5/8 is positive and 3/8 is negative. So we're going to use the second half of the rule, and it says different signs subtract. So let's go ahead and subtract these. We have 5/8 minus 3/8, and I'm always just writing this vertically because I just want students to get in the habit of doing so, especially when it comes to mixed numbers. So 5 minus 3 is going to give us 2 in our numerator, 8's going to stay the same in our denominator. And then the other half of the rule says keep the sign of the bigger number, then you'll be exact. Well, 5/8 was bigger and positive, so we want to make sure our final answer is positive in this scenario. But then we also want to check to see, well, can you simplify this at all? Well, 2 and 8 are both divisible by 2, so we can simplify this a little bit by dividing by 2 in the numerator and denominator. So our final simplified answer is going to be 1/4 for number 2. And then again, I'm going to get rid of all of this and rewrite 1/4, and it's positive because 5/8 was bigger and positive. So we want to keep the sign of the bigger number, and then it says then we'll be exact, and we are. Now let's go ahead and take a look at number 3. We have 17 3/5 minus 19. And students always run into a problem here. Well, one's a mixed number and one's not even a mixed number at all. I don't even see a fraction after 19. So what I have them do is, why don't we add a fraction behind 19? Well, we can't add or subtract unless they have a common denominator. So they know that we have to put 5 in the bottom no matter what, or else we can't add or subtract these. Well, what number is going to go in the numerator that's not going to change the value of this at all? Well, it's going to be 0. 19 0/5 is the same thing as just 19. And now they can go ahead and add and subtract these. So we got a common denominator, and now we need to decide, well, what rule are we utilizing here? Well, it's subtraction, so we're going to leave, change, opposite. So we have 17 3/5 that we leave alone. We're going to change subtraction to addition, and we're going to turn 19 0/5 to its opposite and make it negative. Now we're going to utilize our addition rule. Same signs add and keep, different signs subtract. And I don't want to run into my webcam here, so I'm just going to write it on the lower half over here. Let's go ahead and subtract because they're different signs. So we have 19 0/5 minus 17 3/5. Now, this is where students run into a problem here. Well, I can't do 0 minus 3 in my numerators. So the only option that we have here is to borrow. So I'm going to borrow from 19, and I'm going to make this an 18. Now, the only problem is, well, what does my numerator change to? And it all depends upon what number's in the denominator. In this case, the denominator's 5. So we want to add 5 to our numerator. So it's a 0, so 5 plus 0 is just going to give us 5 here. So we have a 5 up top now. And now we can go ahead and subtract this. And I want you to know why this works. Well, if we're borrowing 5, right? Well, what is 5 divided by 5 essentially? Isn't it 1? Didn't we just borrow 1? Which is why we're adding 5 there and not 10. Because if it was 10 over 5, that means we're borrowing 2. Well, that's not what we're doing. We're just borrowing one number. So again, it all depends upon what your denominator is. So if it's a 3, you're going to add 3 to the numerator. If it's 7, you're going to add 7. And now we can go ahead and subtract these. So this was 18 now. 5 minus 3 is going to give us 2 over 5. 18 minus 17 is going to give us 1. And then the second half of the rule says keep the sign of the bigger number, then you'll be exact. Well, 19 was bigger and negative, so we want to make sure that our final answer is negative as well for number 3. So our final answer is going to be -1 2/5. So -1 2/5 for the third one. And now let's go ahead and take a look at number 4. Again, I don't see a common denominator, so let's go ahead and figure out what that is by utilizing least common multiple. So we have 9 and 27. Write out the multiples of 9. Well, 9, 18, 27, and we only have to go one multiple for 27, and we find our match. So for 19 and 25 27s, we don't even have to change that denominator at all. For the other one, we're going to have to multiply the numerator and denominator by 3. So let's go ahead and do that. So times 3 times 3. This is now going to be 5 and 6 27ths minus -19 and 25 27ths. I see subtraction. We're going to use leave, change, opposite. So let's go ahead and do that. We have 5 and 6 27ths. We're going to change subtraction to addition, and 19 and 25 27ths is going to turn to its opposite and become positive. And now we're going to utilize our addition rule. Same signs add and keep, different signs subtract. This time around, they're same signs, so we're going to add them together. So let's go ahead and do that. We have 19 and 25/27 plus 5 and 6/27. 25 plus 6 is going to give us 31. So I'm just going to write over here because I'm going to run out of space. So 31 over 27 still. And 19 plus 5 is going to give us 24. However, we're going to run into an issue here because you're going to notice that the numerator is larger than the denominator. So we have an improper fraction here, and we don't want to leave our answer with an improper fraction. So we need to change this so it's an appropriate mixed number. So I'm going to get rid of all of this here, and all I'm going to do is rewrite it on this side here. So 24 and 31/27. Now, how many times can you fit the number 27 into 31 without going over? Well, 27 fits into 31 one time. So we're going to add a 1 out front. So 24 is going to become 25. And since 27 fits into 31 once, we want to remove 27 from 31 one time. So what is 31 minus 27? It's going to be 4, and the denominator is going to stay the exact same. And our final answer is going to be 25 and 4/27. And it was same signs. They were both positive. So our final answer is going to be positive 25 and 4/27. And now we have our last one here before we have 5 problems that you're going to try out on your own. Okay, so for number 5, I notice once again, well, they're not the same denominator. So let's go ahead and use least common multiple here. So we have 3 and 12. 3, 6, 9, 12, and we just have to go one number for 12, and we get a common multiple of 12 there. So we don't have to change 11/12 at all. For 3 and 2/3, we're going to multiply by 4 in the top and bottom. So now we get negative 11/12 plus 3 and 8/12. And now we want to utilize our addition rule in red. I don't see subtraction at all. So same signs, add and keep, different signs, subtract. We're going to subtract here. So we have 3 and 8/12 minus 11/12. And you're going to notice once again, you can't do 8 minus 11. So we have to borrow. 3 is going to become a 2. And our denominator this time is 12. So we want to add 12 to our numerator. But this time around, it's not a 0, it's an 8. So 12 plus 8, this is going to make this 20. And now we can subtract properly. So 20 minus 11 is going to give us 9/12. 2 minus 0 is going to give us 2. And we're left with 2 and 9/12. Now we can simplify this a little bit. 9 and 12 are both divisible by 3. So our actual answer is going to be 2 and 3/4, and it's going to be positive because we keep the sign of the bigger number, and 3 and 8/12 was bigger and positive, so our final answer is going to be positive as well. So that's the first 5 questions that I wanted to show you. There's 5 more that I want you to try out on your own. So let's go ahead and get into it. All right, now it's time for the moment you've all been waiting for, the practice session. I want you to pause the video and try out these 5 questions on your own on a different sheet of paper. And when you think you have all 5 answers, come back and play the video and see how you did. Now, I'm assuming at this point you've tried out all 5 questions and you're ready to go over the answers, so let's go ahead and take a look at number 1. You got lucky on the first one. They have the same denominator, so we don't have to worry about utilizing least common multiple. And now we want to decide, well, what rules are we utilizing? I see addition, so we're going to utilize the rule in red. So same signs, add and keep, different signs, subtract. I notice that they're the same signs, so we're going to add and keep the sign that they have in common with each other. So we have 15 and 7/9 plus 11 and 4/9. So when we go ahead and add these here, well, 7 plus 4 is going to give us 11 in our numerator. 9 is going to stay the exact same. 15 plus 11 is going to give us 26. And we want to make sure, of course, that this is negative. However, I notice we have an improper fraction, so we want to go ahead and correct that. So how many times does 9 fit into the number 11 without going over? Well, 9 fits into 11 one time, so we're going to add a 1 out front. So this is going to become a 27. And since 9 fits into 11 once, well, let's remove 9 from 11 one time. So 11 minus 9 is going to be 2, and the bottom number is going to stay the exact same at 9. And again, we want to make sure that this is negative. So my final answer for the first one is negative 27 and 2/9. So hopefully you're 1 for 1. Now let's go ahead and take a look at number 2. This time around, we need to find a common denominator, so let's go ahead and utilize least common multiple. So we have 7 and 10. So 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. And for 10, we have 10, 20, 30, 40, 50, 60, 70. And you're going to notice that these lists take a lot longer to figure out sometimes. So our least common multiple is going to be 70 for this one. So let's go ahead and multiply our denominators and our numerators to get 70 at the bottom. So for 3/7, let's go ahead and multiply by 10 in the denominator and numerator. And for 9/10, we're going to multiply by 7 at the top and bottom. So for this, we're now going to change it to be 30 over 70 plus negative 63 over 70. Now we want to utilize our rules. Well, which rule are we going to use here? It's an addition problem. So same signs add and keep, different signs subtract. I notice that they're different signs. One's positive and one's negative. So we're going to go ahead and subtract these. So we have 63 over 70 minus 30 over 70. Well, 63 minus 30 is going to give us 33, and our bottom's going to stay the same as 70. So our final answer is going to be 33 over 70, but we want to make sure that we keep the sign of the bigger number. Well, 63 was bigger and negative, so we want to make sure that our final answer is negative as well for number 2. So our final answer, fully simplified, should be negative 33/70 for the second one. So let's go ahead and get rid of all this work so it doesn't interfere a little bit later on, and then we'll just rewrite our final answer here. So we have negative 33 over 70. And now let's take a look at number 3. Very similar to the other ones that we did together. Let's go ahead and make 11 into a mixed number. And we're going to do that by just putting 0/6 behind it. Now let's utilize our rules. They already have the same denominator. So we're going to utilize leave, change, opposite because it's a subtraction problem now. So let's leave the first one alone. So 8 and 5, 6 is going to stay the same. We're going to change subtraction to addition, and 11 and 0/6 is going to turn to its opposite and become negative. Now, utilizing our addition rule, same signs add and keep, different signs subtract. These are different signs, so we're going to go ahead and subtract these. I'm just going to write it down here. So we have 11 and 0/6 minus 8 and 5/6. You can't do 0 minus 5, so we have to borrow. This becomes a 10. Our denominator is 6, so we want to add 6 to our numerator. So 0 plus 6 is going to make this 6. And now we can go ahead and subtract these. 6 minus 5 is going to give us a 1 up top. 6 stays the same. 10 minus 8 is going to be 2. And, well, keep the sign of the bigger number. 11 was negative, so our final answer needs to be negative as well. So our final answer is going to be negative 2 and 1/6 for number 3. And now let's go ahead and make our way to number 4. So again, we don't have the same denominator, so let's go ahead and do that by utilizing least common multiple. So we have 9 and 27. Well, the multiples of 9 are 9, 18, 27, and then for 27, we just need to list the first one, and we get our match here. So let's go ahead and change negative 4 and 2/9 to get 27 on the bottom by multiplying the top and bottom by 3. When we do that, our new problem is going to be negative 4 and 6/27 minus negative 19 and 22/27. And now we can decide, well, what rule or rules are we utilizing now? I see subtraction. We're going to use leave, change, opposite. So we leave the first one alone. We're going to change subtraction to addition. And 19 and 22/27 is going to turn positive. Now we want to utilize our addition rule. Same signs add and keep, different signs subtract. Well, these are different signs, so let's go ahead and subtract these. So we have 19 and 22/27 minus 4 and 6/27. 22 minus 6 we can do. We're going to end up getting 16 in our numerator, 27 in our denominator, and 19 minus 4 is going to give us 15. And we keep the sign of the bigger number. Well, 19 was bigger and positive, so our final answer here needs to be positive as well. And 16 and 27 can't be simplified at all, so this is our final fully simplified answer, 15 and 16/27 for number 4. So let's go ahead and write that over here. So we had 15 and 16/27, and that's positive. And then we're on our very last one. So hopefully you're 4 for 4 right now, going into the very end here. So again, we need a common multiple here. So 3 and 18. So 3, 6, 9, 12, 15, 18. And once again, we only need to write 18 and we get our match. 13/18 we don't have to change at all, but 3 2/3, it looks like we're going to have to multiply by 6 here to get 18 in our denominator. So we get negative 13/18 plus 3 12/18. I see addition, so we don't have to use leave, change, opposite. We're going to utilize our song here. Same signs, add and keep, different signs, subtract. I see different signs, so we're subtracting here. So we have 3 12/18 minus 13/18. And I can't do 12 minus 13, so I have to borrow. This becomes a 2. And we're going to add 18 to our numerator because that was what our denominator number is. So 18 plus 12 is going to make this 30. Now we can go ahead and subtract these. Well, 30 minus 13 is going to give us 17 in our numerator, 18 in our denominator. 2 minus 0 is going to give us 2. And our final answer is going to be 2 and 17/18. And it's positive because we want to keep the sign of the bigger number. Well, 3 and 12/18 was bigger, so our final answer needs to stay positive. Hopefully you went 5 for 5 on these practice problems. And if you did, please leave a like on the video, letting me know that this video helped you guys out. Leave a comment on any other topics you want to see. And of course, subscribe. Turn on that bell for post notifications. I appreciate you guys taking the time to watch, and we'll see you in the next video with some more mathematics. Thanks, guys.